The topics in this section focus on several features of two-dimensional graphics that aren't covered elsewhere in this course. We'll look at brushes, and in the next section we'll look at transforms. You've already learned about shapes and geometries, but you also need brushes and transforms to create two-dimensional graphics. Have you ever used a complex brush? Never used a brush at all? Well, you have. There's no way to work around it. Every time you set the fill property, you've used a solid color brush, whether or not you knew it. That is, a single solid color. No matter what brush you use, system.windows.media.brush class is the parent for them all. Well, what is a brush? A brush provides a means to paint or fill an area with output. And there are several different kinds of brushes. There's a solid color brush, which paints an area with a solid color. There's a linear gradient brush, which paints with a linear gradient, gradually changing colors along a line. There's a radial gradient brush, which paints with a radial gradient starting at a point and ending at a circle, again following a straight line going from one color through possibly other colors to a final color at the circle. And there's an image brush, which paints with an image. There are other brushes as well. We'll focus on these in this section. Let's start with the solid color brush. The solid color brush is the simplest brush, and it does just one thing. It paints an area with a solid color. Now, it might be a fill for a rectangle, it might be the background for a cell, might be the foreground for a text font. But every time you select a solid color, you're actually using a solid color brush. There are a number of different ways to select a color, and these don't just apply to a solid color brush, they also apply to gradients, but it's worth talking about now. You can use predefined colors by name. You can specify red or medium blue, and the rendering engine will know what you're talking about. You can choose a color from a 32-bit color palette, and there are a number of different ways to do this. You can use either this format, which is hashmark RRGGBB, where RR is a red value, GG represents a green value, and BB represents a blue value between 0 and 255, or in hex, between 0 and FF. And that's what you'll need to use, the hexadecimal value, if you're using this format. You can also specify an alpha value that indicates the opacity, where in this case FF is totally opaque and 0, 0 is transparent. So in that case you would have a hash mark and 8 numbers representing the opacity, the red, the green, and the blue portion of the color. Now you can also use the property.element syntax to describe the solid color brush, because that allows you to use both a named color and specify its opacity. We'll see an example of that coming up. Now you can use named colors, as I mentioned. That's the simplest way to use them. And you can choose from any of these colors. These are all named, and you can see that for each named color there's also a hexadecimal representation. Now the hexadecimal representation of a named color always has an alpha part of FF, which means it's fully opaque. You can change that by modifying the opacity property, as we'll see in just a bit. You might end up with code that looks something like this. You might have a rectangle whose margin is set, whose width is set, but the fill color is set to a named color, and the stroke is set to a named color. As a matter of fact, we have an example that shows exactly this. You can also use either of the hexadecimal value syntaxes. You can specify either one or the other, and each pair of letters represents 2 hex digits, where RR is red, BB is blue, GG is green. Hashmark FF represents white, fully saturated, and hashmark 000000 represents black. There's no red, no blue, no green, it's black. For example, hashmark 00FF00 represents a fully green color. You can also specify the opacity by adding an alpha value. In that case, you'll have 8 digits, where AA contains a value between 00 and FF. FF is fully opaque, 00 is fully transparent. Now there is a named color, transparent, which has an alpha value set to 0. It's the only named color where the alpha value isn't FF. It doesn't matter what the other 6 digits are, because if it's fully transparent, who cares what the other colors are? But every other named color has the alpha value set to FF. You can also use the more verbose element.property syntax because you get the best of both worlds. You can use a named color, and you can also specify the opacity property. For altering opacity at runtime, this is the best choice because it's difficult to programmatically modify 2 of those values in a hexadecimal representation of a color. You might end up with code that looks like this. We have rectangle.fill. Rather than just setting the fill property to be a single value, you use the element.property syntax, and you can set the rectangle.fill property to be a solid color brush whose color is red and whose opacity is, well, some value between 0 and 1. By doing that, it's very easy to programmatically change that opacity property. Let's look at an example that demonstrates everything we've seen so far. In this example, I've extracted the useful portions of the markup and have placed them on the demonstration itself, so we don't have to keep flipping back and forth. Here we have a rectangle shape with its fill property set to plum and its stroke set to yellow, and therefore we get exactly that. Here we have an ellipse shape with the fill set to blue and the stroke set to fuchsia, and we get those colors. Finally, I have some text with its foreground property set to salmon, and those are the colors we see in the output. Now those examples use named colors. The next examples use the hexadecimal representation of the colors. In this example here, we see our fill set to this color, which I just sort of made up randomly, and stroke set to this color here. You can see in this case, in the fill, I've specified the AA, RR, GG, and BB values, FF meaning fully opaque. In the stroke, I didn't bother. I just assumed we wanted it fully opaque. In this example here, I have the rectangle set for its fill to be opaque and have ADFF2F as its fill, and the stroke is opaque and it's got 0000CD as its color. For the ellipse, I have the fill set to BFFF000. Well, what is FF0000? That should be red, and the fill is red, but the opacity isn't quite FF. It's a little less than FF. It's BF, and you can see that you see through that because it isn't completely opaque. The stroke is set to be completely opaque in some color here, 191970, doesn't matter what the exact color is, but you can see it's opaque while the fill is not. So you can modify the opacity of a color by setting the AA value to something other than FF. Now here I'm using the element.property syntax, and I've bound the opacity property to the value of a slider. So you can see I have element.property syntax. I'll have rectangle.fill, and within that I'll create a solid color brush, and the solid color brush has a color of red, but the opacity uses a binding. The element name is opacity slider. Here's my opacity slider, and now as I slide this, the color becomes less and less opaque. And as I move it farther to the left, at some point, you can see the text appear beneath it. Have fun playing with that. It's kind of a nice effect. You could do this on a timer or on a slider, as I've done here, but in any case, as you change the opacity, the text beneath that rectangle becomes visible. If I set the slider back to 1, the opacity is set to 100% again, and we can no longer see the text underneath that rectangle. A linear gradient brush instance paints an area with a linear gradient. Looks something like this. Reminds me of the 60s in tie-dye. You probably weren't old enough, but that's the effect you get. Normally you don't use 4 or 5 colors, as I have in this demonstration. You control the direction and the position of the gradient. You control the colors that make up the gradient, and you control the locations at which those colors change. Now, the linear gradient brush defines a color gradient along a line. You set the gradient line's endpoints using the start point and end point properties of the linear gradient brush. The default line gradient in Visual Studio is diagonal. If you just create a gradient, that's what you're going to get. The endpoints will be at 0, 0 and 1, 1. Clearly, the upper left corner is 0, 0, and the lower right corner is 1, 1. What that means is the coordinates are relative to the container. Doesn't matter what size your container is, 0, 0 is the upper left-hand corner, 1, 1 is the lower right-hand corner, and that makes it easy for you to create proportionally set up endpoints for the linear gradient brush. All you have to know is that it's proportional to the size of the container you're putting this in. By default, the endpoints are at the upper left corner and the lower right corner. Imagine a line that connects the upper left corner and the lower right corner. That will be the line along which the colors change. To set up the colors, you'll need to add one gradient stop to the brush for each color you want displayed within the linear gradient. For each gradient stop, you can provide an offset along the line that you created using the start point and the end point. At the offset point, that is, at the point you specify, the color is 100% saturated. The offsets range from 0 at the start point to 1 at the end point. This whole system is very simple. It's all based on proportional coordinates based on the size of the container. So here you can imagine yellow at stop 0, green at stop 3, red at stop 1, and blue at stop 2. Stop 1 is some proportion of the distance from stop 0 to stop 3, and stop 2 is some proportion of the distance between stop 0 and stop 3 as well. So stop 1 might be at 0.25, stop 2 might be at 0.75, stop 0 is at 0, and stop 3 would be at 1, the endpoint of that line. Now you can rotate the gradient by modifying the start point and end point properties. And even if you don't like the relative coordinate mapping system, you can set the mapping mode property of the brush to absolute. However, the default is going to be relative to bounding box. And here's an example that shows off what happens if you rotate that line. Rather than going from 0, 0 to 1, 1, if you make the line go from 0, 0.5, to 1, 0.5, this is what you get. And by the way, if you think about it, you'll realize that if you go from left to right in this way, it doesn't matter what the y-coordinate is. If the line is horizontal, the y-coordinate can be anything at all because you're going to get vertical stripes of color. Same thing happens if the line is vertical. Doesn't matter what the x-coordinate is because you're going to get horizontal stripes of color in that case. You can specify whatever you want for the other coordinate when you're using a vertical or horizontal line to define your gradient. The offset property indicates the gradient stop location along the gradient line. It has to be between 0 and 1. And as the offset property is altered, it alters the point at which the fully saturated color starts. Let's look at some examples which demonstrate this behavior. In this demonstration, I've created pretty much the same linear gradient brush a number of different times to try out different features of that linear gradient brush. The last example is slightly different, but let's look at the markup that creates this linear gradient brush here. You can see that I have a rectangle. I'd like to fill it, so I set the rectangle.fill property equal to this linear gradient brush. I have to use the element.property syntax because what I'm putting into that property can't be represented in a single string. Here I have a linear gradient brush whose start point is 0, 0 and his end point is 1, 1. That's the default. I didn't have to type it. Down here I have within there 4 gradient stop elements. Each one represents one of the colors I'd like to display in that linear gradient. starting with yellow at offset 0, red at offset 0.25, blue at offset 0.75, and lime green at offset 1. You can see that in the output we have yellow, red, blue, and lime green at offsets, and we can actually see that in the next two diagrams. Here we see the linear gradient line going from 0, 0 to 1, 1. I've drawn it on the diagram so you can see it. On the next diagram, I've drawn on the linear gradient line and also represented each of the stops so you can see where they appear along that linear gradient line. If you're interested in the markup, you can go look at those, but all I've added is the dashed line and the points. The next example, however, changes the gradient line to not be diagonal, but instead be horizontal. Here it goes from 0 and some value to 1 and some value, and because the line is horizontal, we don't really care what that some value is. I use 0.5. It could have been any place vertically within the rectangle. We get vertical lines of color. Again, we have yellow here, green at 1, red at 0.25, and blue at 0.75. Now we can also take that same concept and change the start point and end point so the line isn't horizontal. It isn't diagonal, but it isn't horizontal or vertical either. Here we go from 0, 0.35, to 1, 0.65. That line is slightly tilted, and so the bands of color in the gradient are slightly tilted. Now you might want to change the offset and see how it affects the behavior. Our beginning offset is 0, our ending offset is 1 in every example we've seen so far, but what if that isn't the case? Let's look at the markup for this example, which is way down here at the bottom. Here we are, and we have here a rectangle whose rectangle.fill property is set to a linear gradient brush, and the linear gradient brush has, well, you can see first of all it's horizontal, goes from 0 to 1, the y coordinates are the same, and the gradient stops are yellow and blue, but the offsets are set by binding to a slider on the page. You can see the slider for yellow is set to 0, and the slider for blue is set to 1. If I drag the slider in, you can see I change the value of the blue offset to 61% or 0.61, and you can see that the solid, fully saturated blue happens at 61% of this rectangle. What happens to the rest of the space if the offset doesn't end at 1? Well, by default, and although you can change this behavior, and we'll see how in a moment, the default behavior is to just pad the rectangle or the container with the same color that ended at 0.61 for the rest of the container. Let's try the other side. The same thing happens on the left hand, or the beginning side of the gradient. If the offset for yellow is 0.47, then everything from 0 to 0.47 appears in the color that starts or becomes saturated at 0.47. This behavior pads out the extra space within the container, and you can change that behavior if you like. But that's the default behavior, padding out the filler space with the most obvious color choice. What happens if the gradient doesn't extend fully across its bounding area? A gradient doesn't necessarily fill its entire area. The default behavior pads the extra space with the most local color from the gradient, as you saw in the yellow and blue example. There is a brush.spread method property which controls this behavior. Pad, which is the default, uses a solid fill of the appropriate color. There's reflect, in which areas outside the gradient fill painted in the original gradient in reverse order, and that provides a reflected look. There's also a repeat option, where areas outside the gradient are filled, painted in the original gradient, repeated until the area has been completely filled. And we'll look at examples of pad, reflect, and repeat in the demonstration. One thing to note is that linear gradient brushes aren't restricted to rectangular areas. You can fill anything at all. You can fill an ellipse or text or anywhere you need a brush. Even the stroke for a line can be a linear gradient brush. Let's look at some examples which demonstrate these features. Let's take a gradient which has a start point of 0.50 and an end point of 0.51. Basically a vertical gradient going from 0 to 1, where yellow starts at 0 and blue starts at 1. And you can see there's our gradient right here that defines it. Start point, end point, color, offset for one gradient stop, color and offset for the next gradient stop. Now what happens if the gradient starts at 0.50 and ends at 0.5 but 0.25 doesn't even begin to fill the whole thing? That is, the gradient ends right here at 0.25. We can see we go from yellow to blue. What happens to the rest? Well, in this case, by default, the pad spread method gets used. We pad the rest with the most local color. Now, if we take that exact gradient but set the spread method to reflect, in that case, we get yellow to blue for 1/4 of this rectangle. Then we do it the opposite direction, blue to yellow for the next quarter. Then we start over again, yellow to blue and blue to yellow. So the pad in that case reflects the gradient that we'd created. Now, remember in this example, I had my gradient take up exactly 1/4 of the space. You could, of course, have your gradient take up something which wouldn't fill the whole thing, and you'd get a different effect altogether if you set the spread method equal to reflect. If you set spread method equal to repeat, as I've done in this example, we'll get our yellow to blue gradient for the first 25% of this rectangle. Remember, the end point is 0.25. And with the spread method set to repeat, everything just repeats until we've filled the entire container area. If you look at the markup for that example, the only thing that's changed from this version to that one is we've set the spread method equal to repeat. And that's the only difference. Same exact gradient otherwise. In our example now, we're also showing off what happens if you put a linear gradient brush within something that isn't a rectangle. Here I've used a fill property to fill an ellipse with the linear gradient brush you saw in the previous example. Now, why don't we see the yellow color or the green color? Well, because when you create an ellipse, you define it using rectangular coordinates. So the yellow portion is up here somewhere, the green is down here somewhere, but because we're truncated by the ellipse, we just don't see those colors. The same thing happens when you use a linear gradient brush as the foreground property of some text. Here we have a large piece of text with the foreground property set to a linear gradient brush. If we look at the markup for that, you'll see down here a text block with its textBlock.foreground property set to a linear gradient brush defined here, which means that we see as the foreground property of our text a tie-dye like rainbow set of colors. Cool. The radial gradient brush class works much like the linear gradient brush. That is, gradient stops appear on a single line, but in this case, that single line goes from the center of a circle to the edge of a circle. The stops apply in a circular manner as opposed to a linear manner, so you supply the gradient stop along that line, and colors extend all the way around a circle. The gradient stop elements look exactly the same as in a linear gradient brush. So you can copy and paste the gradient stop elements. It's just the outer radial gradient brush element that defines slightly different behavior. As with the linear gradient brush, you can include as many gradient stop elements as there are colors required. And as with the linear gradient brush, the radial gradient brush draws the gradient along a line. That line extends from a single point specified by the gradient origin property, which by default is at the center of the circle, to the edge of the circle. And just like the linear gradient brush, this uses a proportional coordinate system, where 0, 0 is the upper left-hand corner and 1, 1 is the lower right-hand corner of your container. Once the radial gradient brush reaches the edge of the circle, the remainder of the area is filled in with the outermost color. By default, the origin is at the center, 0.5, 0.5. You can change the gradient origin property to alter where that center is. And the fill area can be non-circular. Just like with a linear gradient brush, you don't have to fill rectangles. With a radial gradient brush, you don't have to fill circles. You can set the radius x and radius y properties to change the shape of the gradient. It doesn't even have to be circular. It can be elliptical if you want. And note, this is tricky, that the radius x and radius y properties measure a fraction of the diagonal span of the fill area. That is, they're proportional to the diagonal span of the fill area you're talking about. You can also set the spread method property, as we've done before, to pad, reflect, or repeat. And we'll look at an example of working with that property. Well, let's look at some radial gradients and see what they look like. In this demonstration, we'll look at a number of different radial gradient brush examples, starting with a simple one, which takes us from yellow at the center to green at the outer edge. I've used a stroke of blue here. I'm not sure why, but we do see from yellow to green along the radial line from center to the edge of this ellipse. What does that markup look like? Looks something like this. We have our radial gradient brush with 4 gradient stops in it. Looks exactly the same as a linear gradient brush. The only difference is the keyword radial gradient brush on the element name, and we place it inside an ellipse, and we're using ellipse.fill as the property we're setting with this radial gradient brush. We go from yellow at 0 to lime green at 1, so we imagine a line that goes from here to here, which defines as we go from yellow to red to blue to lime green. Now what if we take that same radial gradient brush and place it inside a rectangle? Looks pretty much the same, except now we pad with the outermost color. If we look at the markup for this one, we have, here we are, a rectangle. That actually was the rectangle I was pointing at. Darn. The same exact thing happens for an ellipse, but now for a rectangle, the only difference is we're filling a rectangle with the radial gradient brush. By default, the spread method is set to pad, and so we pad the external space with the outermost color. Now, nothing says you have to have the offset right at the center. Now, nothing says you need to start your gradient right at the center. You can offset that center using, here, the gradient origin property. The gradient origin property of the radial gradient brush allows you to specify exactly where you want the center to be. Now, these coordinates are relative to the bounding area, with 0, 0 at the upper left-hand corner and 1, 1 at the bottom right corner. So 0.7, 0.2 moves us over 0.7 in the x direction, 0.2 down in the y direction, and now we draw the gradient which starts at yellow and ends in blue, starting at that point. You can see what we end up with. Because we've moved the gradient out of the center, we end up with some blue padding on the edges. Nothing keeps you from moving that center outside the fill area. Right now it's inside the ellipse, but it could be outside the ellipse. If we look at the markup for this one, only thing I've changed is I've moved the gradient origin so that the x-coordinate of that origin is outside the bounding region. Right now it's over here somewhere, and you can see that we get a completely different look for that gradient. It kind of looks like a light is shining on a pool ball or something. In any case, you can experiment with where that center goes and see what it does to the radial gradient that you create. The radial gradient doesn't even have to be circular. You can set the gradient fill area by specifying a radius x and radius y value on the radial gradient brush. Radius x gives you half the distance across, and radius y gives you half the vertical distance, and those distances are measured in proportion to the length of the diagonal of the fill area. So when we say the radius x is 0.7, we mean it's 0.7 or 70% of the diagonal length. That's why this x radius fills almost the entire space, because it's 70% of this diagonal, which is slightly longer than this length here. When we say the radius y is 0.3, it's 30% of this diagonal, which means it goes way more than 30% of this vertical space. In any case, radius x and radius y are measured in proportion to the length of the diagonal radius, and so they may be longer than you expect. So you can see that this is an oblong shape for my radial gradient brush, where radius x and radius y are defined in proportion to that radius of the area. Now, so far, every example we've seen that spills outside of the radius of the gradient has used pad for the spread method. So here we get blue on the outside, here we have green. What if you want something different? Well, I've taken this exact example, and the only thing I changed was the spread method. Well, I actually put it inside an ellipse as well, as opposed to a rectangle. But I've changed the spread method to be reflect, not pad. And so what you see here is the gradient going from 0, 0. You know what I also changed? Darn. I also changed the radius x and radius y to make it a smaller area. Radius x is 0.3, radius y is 0.2, spread method is reflect, but the gradient stops haven't changed. If we look at the example, we have a very small elliptical region for our gradient. It starts here and ends about there, starts here, ends about there. We've set the spread method equal to reflect, and so the radial gradient brush appears in reverse order starting at the edge of the first presentation. So we go from 0 to whatever, here's 0.2 or 0.3, and then from there reflect, which means we go from blue back to yellow in the same size gradient. You can see that our gradient area isn't circular because we have this band of yellow which forms the edge of the area where we're reflecting the second time, and you can see that's not circular. In any case, you can see how many properties you have for working with the various behavior of the radial gradient brush. You can entertain yourself for hours trying various means of displaying the radial gradient brush. The image brush class uses images for filling, backgrounds, borders, and more. You need to specify the image source property, and then you get an image. The default behavior is for the image brush to stretch the image to completely fill the bounding area, and that may distort the image. You can set the stretch property to control that behavior. The fill value, the default, means the image stretches and may distort. None means the image appears at its native size and may clip. Of course, if the image is too big for the bounding area, you'll just get what fits. You can use uniform, in which the size is increased until it reaches the edge of the container in one of the directions, either width or height, and it may leave empty space. You end up using the smaller of the width or the height of the container. Uniform to fill means the size is increased to fill the space. You use the larger of the width or the height and may clip the image. So fill doesn't clip, but it might distort. Uniform doesn't clip, but you might end up with empty space. None displays things in the native size, but definitely will clip if the image is too large for the space. And uniform to fill will almost always clip your image because it won't exactly be the same proportions as the parent container. You can use the image brush any place you can use any brush, including foreground for text. Remember, all brushes can be used any place any brush is required. Let's look at some examples that demonstrate using the image brush class. In this demonstration, we'll show off working with images and various fills using the image brush. We have pictures of cute animals starting with a kitten, and who doesn't love kittens? Here is the actual image itself, and now I'd like to use it as an image brush. In this case, we'll fill an ellipse. So let me look at the markup for this. Here we have an ellipse, width of 180, height is 120, and we have the ellipse.fill property set to an image brush, whose image source is set to the images folder and the kitten.jpg file that's in that folder. Since we haven't specified the stretch property, here it stretches it to fill the entire space. We not only truncate, but we also end up distorting the image because that ellipse is wider than the original image was. Since we haven't told it what to do, it just stretches it out to make it fill that space. Now if we set stretch to none, and that's all I'm changing in the next 3 examples here, if I set stretch to none, then we get the image not stretched, but in its original size. Here I shrunk it some to fit. Here's the original size, and all we see is the truncated part that actually fits within the ellipse. The interesting part is they do, apparently, attempt to center it within that space. Here's stretch equal to uniform. This uses the minimum of the width and the height of the image to make it fit. Now here we've got the entire image, side's a little truncating here because of the shape, but the entire image has been resized to fit within that space, and we do see the entire image except for the part which had to get truncated because of the shape of the container. If we use uniform to fill, now we use the larger of the width and the height of the container, there's the width, and we fill that space, but now we truncate more of the image because we've zoomed in on that image. So you can see using the default, which is fill, which causes stretching. Here is stretch equals none, which means we use the natural size. Stretch equals uniform, use the smaller of the width and the height. Stretch equals uniform to fill, use the larger of the width and the height, which causes more truncation here. All right, well, what can we do if the image is smaller than its space? In that case, you might want to set the alignment X and alignment Y properties to control where the image appears within its container. Let's look at that final example down here. You can see I have a rectangle, width and height are 200. I'd like to display the dog.jpg file, which is clearly smaller than the rectangle I've specified. I can indicate where it goes by setting the alignment X and alignment Y properties for that image brush, and you can see that it appears at the right and bottom of its container, and by putting stretch equals none, we get the native size for that image. So we end up with a picture of a dog in the lower right-hand corner of its container. There's nothing keeping us using an image brush as the foreground property of text as well. So here you can see I've got the text kitten, and I'm using the image of the kitten as the foreground brush for that text. You do it just like any other brush. You specify textblock.foreground, and within there put the image brush. And the image brush is laid out exactly as it is here. You may not specify alignment X or alignment Y, but you do specify the image source property, and you end up with text displaying a picture of your kitten. Just about every brush you've seen so far, okay, with a few exceptions, have been completely opaque. XAML supports transparency, and you can layer elements and see through to lower layers. You can create a background that shows through, for example. And there are several ways to do this. You can set the opacity property of an element to a value between 0 and 1. 1 is fully opaque, 0 is fully transparent. You can set the opacity property of a brush that fills the element and get the same behavior. You can set the alpha channel of a color to be a number between 0 and 255 and control the opacity in that way for that color. And you can set the opacity mask property, and this allows you to supply a gradient brush that defines the transparency, so you get a gradual fade on the transparency if that's the kind of thing you want. Let's start by looking at the first options. We'll look at opacity mask separately. In this example, we're using a kitten as a background image to a canvas, and then placing various other elements on top of that background image. We have a text block, a rectangle, an image, control, and another text block on top of that. And everything is somewhat transparent in this demonstration. Let's look at the markup to see what's going on. First of all, we have an image brush providing the background property for the canvas we're looking at. You can see its opacity property is set to 0.5. So the kitten is vaguely transparent, basically halfway opaque. And you can see it looks pale, the image looks pale, because the white color from the background, or the gray color from the background, is showing through. Then we have a rectangle here with its fill color set to a number, a value for the fill color, which is not completely opaque as well. Using 80 as the alpha value means that this rectangle is slightly transparent, and you can see through to the background image behind it. Then we have a text block with its opacity property set to 0.2. So it's only 20% opaque, and it's got the text transparent kitten in it, and you can see in the diagram, and you can see in the image my 20% opaque transparent kitten text here, and you can see the kitten's fur through it. Then we have an image here, and we've set the opacity of that element to be 0.5. So you can set the opacity of an element and get the same behavior. Here is my dog looking halfway opaque, and if you look hard, you can see bits of the image from underneath showing through the dog image. Finally, we have a text block, again, with its opacity set to 0.2, and so the text block shows the image below it showing through. I'm not saying much kitten showing through at that point, but you can definitely see the dog image showing through. So in this example, you've seen a number of different ways of making things be less than opaque. You can set the opacity property of a brush. You can set the alpha value of a color used for a fill. You can set the opacity property of an element. And the last method, which we haven't seen yet, we'll look at next. You can use any brush you like. However, a solid color brush isn't very useful for this. It would be simpler just to set the opacity of the element, or of the color, rather than using opacity mask with a solid color brush. Only the alpha channel matters in an opacity mask. Any color portion you have is insignificant and is disregarded. You can also use the transparent named color as one endpoint of your opacity mask. Normally you set the opacity mask to be a gradient of some type, with transparent as one endpoint of that color. So you end up with completely transparent at one endpoint or another. You can use the transparent named color, which is defined as 00 and then something. I don't know what the something is, and it doesn't matter, because once you become transparent, the color is insignificant. And of course, with an opacity mask property, only the alpha value matters anyway. So let's look at an example which demonstrates using the opacity mask. In this example, we have the cat JPEG file acting as the background for a canvas. We also have a button here, which is somewhat transparent, and an image here, which is somewhat transparent. Now this one is pretty cool. This one has a radial gradient providing the opacity mask, so it becomes transparent along the edges, but the center is completely solid. This one uses a linear gradient brush as the opacity mask, so it becomes transparent toward the bottom of the button. Let's look at the markup for the button and this image to see how they're working. First of all, we have an image brush providing the background property for our canvas using cat.jpg. We have a button here with its opacity mask property set to a linear gradient brush. The opacity mask property would normally contain a gradient of some sort, and here you can see a start point is 0, 0, end point is 0, 1, which means it's a vertical gradient line, and the gradient goes from red to transparent. You can't really see the red here. Can you see the red? No, you really can't see it there. But in any case, oh, I did that for a reason. The reasoning was, in an opacity mask, the color itself is insignificant. All that matters is the alpha channel, and the color red is fully opaque. So we're fully opaque at the top and fully transparent at the bottom. Transparent is a special named color which has 0 in its alpha channel, so we go from solid at the top to completely transparent at the bottom. And that's what the opacity mask property does for you. You provide a gradient, it then uses that to define the opacity of the element itself. Think of it this way. As the gradient becomes less opaque, the button becomes less opaque. The same thing happens down here. I have an ellipse. I'm going to use as its fill property an image brush, getting my kitten. Now if I just drawn that, it would be larger and have a solid border around the edge. It would be the kitten's image sitting right here like a plate on this image. But that's not what I wanted. I wanted to fade out on the edges. So we're using as an opacity mask a radial gradient brush going from fully opaque to fully transparent. Again, this color doesn't matter. Any named color would have the exact same behavior. And we go from opaque to transparent at the edge of a 120 by 120 sized ellipse. So that's about this big. And actually you can see a little bit of it bleeding out over here as it becomes fully transparent on the edge. In any case, think of what fun you can have using opacity mask to make things fade out on their edges. Remember that the actual colors don't matter, it's just the opacity that matters when you're using the opacity mask property.